8.5, solving rational inequalities. These are some problems that you can practice on. Solving rational inequalities algebraically. Okay, so solving an inequality means that we need to find the set of numbers that make the inequality a true statement. So let's do an example. We have x minus 5 over x is greater than 2. To solve the inequality, we will have two cases. So case 1. The least common denominator is positive. In case 2, the least common denominator is negative. Okay, so step 1. We want to solve for x. So I will multiply both sides by x. So x minus 5 is greater than 2x. I want to move my x to the other side. So then I get that x is less than negative 5. Step 2. We want to consider the sign of the least common denominator. In this case, we said it was positive. So we're going to say that x is greater than 0. So as you can see, we have two possible solutions. X is less than negative 5, and x is greater than 0. So we're going to test them both. For x is less than negative 5, I'm going to test x equals negative 6. So x minus 5 over x is greater than 2. If I plug in my negative 6, I get 11 over 6 greater than 2, which is false. Okay, so now I'm going to test when x is greater than 0. So if x equals 1, then I'm going to get 1 minus 5, which is negative 4, over 1, greater than 2. It's false. Okay, so now let's go over case 2. Same step. Step 1. We solve for x. Remember that our least common denominator is negative. So when you multiply by a negative value, we must reverse the inequality symbol. So now we will have x minus 5 is less than 2x. And we want to solve for x. So negative 5 is less than x, or we can say that x is greater than negative 5. Step 2. We want to consider the sign of the least common denominator. In this case, it was negative. So we're going to set x less than 0. So as you can see, we have two possible solutions. X greater than negative 5, and x is less than 0. Let's test the value. What if we have x equals to negative 4? We go back to our original inequality. So then we have negative 4 minus 5, which will give us negative 9 over negative 4. Is greater than 2. That's true. Okay, now let's check when x is less than 0. Okay, let's test x equals negative 1. So negative 1 minus 5 will give us negative 6 over negative 1, which is 6. 6 is greater than 2. So that's true. Therefore, the solution set of the original inequality is the union of the solutions on case 2, which we can write as x greater than negative 5 or x less than 0. We can also write it using set builder notation. So the set of all x's such that x is greater than -5 and less than 0. Let's do another example. What if we have 8 over x plus 5 is less than or equal to 4? Once again, we have two cases. Case 1. The least common denominator is positive. In case 2, the least common denominator is negative. So our step 1 is to solve for x.